Hello everyone. So this is another stream reviewing the cracking the code interview problems, and we solved permutation in string. What's this? We solved permutation in string. Okay. So let's check the next one. This is Leetcode Premium. I don't have Leetcode Premium, so wanna wait. Let's check this one. Edit distance. Give it two strings, word 1 and word 2. Return the minimum number of operations required to convert word 1 to word 2. You have the following three operations permitted on a word: insert a character, delete a character, replace a character. Okay, so I have horse and I have rose. Explanation, tuple 3. From horse to rose. Okay, rose. Replace H with R. Remove R. Remove E. Okay, I can really tell this is a dynamic programming problem because I set it distance. It's okay. I'm checking if people is in the stream. Is a classic dynamic programming problem. Okay, intention. Word 2, execution. Remove T. Replace I with E. Replace N with X. Okay, I'm not very good with dynamic uh, dynamic programming problems. Let's do a little bit of drawing. Maybe something will come up to me, but I'm pretty sure I will just end up looking the solution up and implementing it. Okay, where is my there it is. Here it is. The program to draw, it's called Splashtop. I open Splashtop. Okay. Okay. There is someone here. Just close Splashtop. Take this, show, play tree. Okay, so edit distance. With hearts. So hearts. Let's see the limits of the problem. Word length 500 lower cases. Okay, let's just wait a moment. Charge. Okay. I need to check if replacing, so this one, this one, this one, this one, this one. And I can also insert. So here I can insert. I can replace, remove, or insert. I need to check all the solutions, and if this is a dynamic programming, if this is a dynamic programming problem, I have a matrix. I usually give the thought of the problem about half an hour. If then I cannot solve it in half an hour, I go to check what is the solution. But seeing that I kind of know this is dynamic programming, the best thing I can do is directly, and knowing I'm not that good with dynamic programming, the best I can do is go directly to check solutions. So let's call the distance. The distance solution.
In this video, we will see how to find edit distance between two strings and what is meant by edit distance. So you have two strings S1 and S2, and your task is to convert S1 to S2. So how many edits you will need? So this string is that much edit distance from this string. So here we are allowed to do certain operations. One is to substitute a given character in the string. Second is to remove a character from the string, and third is to insert a character in the string. So these are the three operations that are allowed. So let's see this example. Here this is S1 and we have to convert to ROS. So let's see how we can convert it.
The normal, when it's not a video, there's just the code. Like, this is the solution, no explanation. When it's a video, it has explanation, so it's better, normally.
So here red denotes deletion, and I have labeled it in yellow to denote substitution. So we can replace this H by R. So what this will become? This will become RORSE after one operation. Next, if we delete this R that is marked in red, it now becomes ROSE, which is very close to this now. And now once we delete this E, this becomes ROS. So we had done three operations. One is substituting H with R, next is deleting R and E. So in total, three operations are required. There can be other ways of doing that also. Let's say you delete these two, so two operations, and you replace this S with, or you insert a O in between, so it becomes ROSC, and then you delete E. So it will take four operations. Even for three, there can be multiple solutions, but in this case, looks like this is the only way. So you have to find the minimum of such operations. So one thing to note is that how can we find that? So let's say this is X and this is Y, and its length is M, and here it's N. That means X has M characters and Y has N characters, and we are asked to find edit distance. Let's call it ED MN. So this denotes take the first M characters of X and N from second string. So there can be a few scenarios. If you look at the last string, last character, these can be either equal or non-equal. If these are equal, then your job is reduced. So you have two strings, their last characters are same, and you have to convert this to this, and this matches. So what you will try to do in the remaining m-1 characters, if you can convert the remaining m-1 characters to this n-1 characters, then your job is done, since the last character is already same. So depending on that, we can have a few scenarios. So if x m-1 is equal to y n-1, then what we will do, we will return ed m-1 n-1. So without even doing any operations, this one string, one character is done for us. So we will not count any operation here. Else, that is, they are not equal, then we will do those three operations. What are those? Substitute, delete, and insert. These are the three operations possible, which we will try all of these in this else case. So if we do any of these, we count it as one operations. So what things we can do? These are not equal now in this case. So what we will do, either we will delete it. We cannot delete this string is fixed. This is the target. So either we delete it and see that we are left with this m-1. So convert this m-1 to this complete n string. Here we have not even got a single character, so this remains complete. So it will be ed m-1 n. So here n does not change. M changes, we have deleted it. So let's mark it deleted. We have to take min of these. What are the operations? This is for deletion, first one. Then we will substitute. So what we will substitute? So these characters are different, and our target is that last character should be this one. Let's call it yn. and this is xn. So we will substitute xn with yn so that this character now becomes same and our task is reduced. So we will look in this m-1 and m-1 since we have substituted this to exactly what it should be. But the difference between this and this case, here also we are finding m-1 and m-1, and here also we are finding that recursively. But the difference is that here 1 is added because we needed to substitute this to yn to make them equal, and here we already had that equal. So that's why here 1 extra operations. And what is the third possibility? We have looked at substitution, deleted, then we insert. Third case is that we insert a character in the end, and that character should be same as this yn, otherwise why would we insert that? Last character has to be yn in this. So we will insert yn. It was not already yn, it was different. So again we have 1 operations. And once we have inserted yn here, this string becomes of size length m+1. It had m, we inserted 1, it became m+1. But last character we don't need to worry about, since that last character is same as this last character, that is what we have inserted. So we will not consider that for our next solution. So we will again be left with m characters only. The last one that we inserted equal to this, we are done with that. So here m will remain same and this n will reduce by 1.
I had to review a whole video. One solution in a stream is a good way to compress my view time, because in this if I solve that, I just stop and go review something, try to do this in steps, because this is quite hard, but it's better to go faster. Okay, so let's keep reviewing.
Since now this character matches with the newly inserted one, we have to look only in this part. So convert this original x to this n-1, and we had inserted the last one. So here either if this is equal, then return this. If the last character is different, try all these things, all these 3 things, and 1 operation will be counted for if you perform any of these, and take the minimum of that. So you see a recursion here. Let's draw the recursion tree then. So mn is the original problem, completely x and completely y, all the characters.
Okay, why is he only changing the last character? Let's just let him finish, and then we try to understand that.
And we broke that into 3 scenarios: m-1n, m-1n-1, and mn-1. And this is also m-1n-1, which is here. So in order to solve mn, we need 3 possibilities: m-1, n-1, m n-1, and m-1 n. These are the 3 problems we need to solve. Now let's look at one of these. Let's say we want to solve this. So for this, again these 3 branches will be there: m-1, n-2, m-1, n-1, and m and n-2. Similarly here it will be m-2, n-2, then
yeah, it's doing the recursion.
m-1, n-2, and m-2, n-1. And similarly there will be 3 branches here also. So let's see if there are any overlaps. So if you see this branch m-1, n-1, it will again be solved further. And now you see that this is already solved here, m-1, n-1. So all these branches which are coming out of this,
the algorithm
is already solved. So there is no need of solving it here again. The same exact same branches will be here below this root m-1 n-1 as this one.
That is
Similarly, there will be other cases as well.
There is optimum structure. You solve the little problem, it helps you with the big problem. So that's what is happening here.
M-1 n-2, m-1 n-2. Again, you see overlap. If you draw more of this, you will see much more overlap. And you will also notice that this problem becomes exponential if you don't save the solution that you have already solved. So here we have one node, here we have 3, here we have 3 times 3, that is 9. Next we will have 3 times 3 times 3, that is 27. So at level k we will have 3 raised to the power k such nodes. So you see clear exponential branching here. So this is the recursion tree, and if we don't solve it, then quickly it will go beyond our control, and if the string becomes large, let's say 20 characters or 25 characters, then this problem will be stuck forever and it will not be solved. So here we will see that dynamic programming requirement is coming in. First requirement for dynamic programming is that overlapping some sub problems. In fact, this is second. First one will be that optimal substructure. And what is meant by optimal substructure? That if you solve smaller parts of a bigger problem, if you find the optimal solution of this smaller problem and this smaller problem and this smaller problem, clearly all of these three are smaller than this mn. So if you find the optimal solution or best solution of these three sub problems, smaller problems, then using them you will find the optimal solution of this bigger problem, original problem itself. And we saw that this will be the case. These are the two possibilities, whether the last character is same or different, and these are the only three problems we need in order to solve this. So we will use dynamic programming here. So we will create one table. We will use tabulation, bottom-up approach. You can also use memoization, top-down. So here let's create the DP table, and I have added one extra cell here. So this denotes y, characters of y, and this denotes x. So this will have m+1 here, m+1 rows and n+1 columns, and our goal will be to find this last one, that is take complete of this x and convert completely to this. So let's see what we will need for that. So if we are here in some cell ij, let's call it ij, then in order to solve this we will need I-1j, which is here, I-1j-1, which is here, and ij-1, which is here. In order to solve this we need these three values. So if we start from this top and go row wise, then next row, then we will always have solved these three parts before reaching here. And now what are the scenarios? These are the scenarios. If the last character is same, then we will need m-1 n-1, that is, if the last character is same, we will simply take this value. Simply put this value here if last characters are same. If they are different, we will take minimum of these three, A, B, C, min of A, B, C plus 1, and that is what we had written here, minimum of these three. So let's start filling this table. So here this denotes that we have not taken any character from x, that is x is empty, and we have to convert it to some one or more characters of this y. So this denotes x is empty, y is also empty. So we don't need any conversion, so this will be 0. This cell will denote that x is empty, y is this first character. So if x is empty, y is r. So what we will need, we will insert r. So it will require one operation. And this will denote x is again empty and y is ro. So this denotes that take from beginning till this. Similarly, this value will denote that take ho and r corresponding to this. HOR convert it to ro. So here empty to ro, so 2, empty to ros 3. We can only insert if it's empty, and here it's not empty. We will make 3 insertions. And similarly this one, here we will do deletion. X is h and y is empty, this column, first column I am talking about. So here we will delete 1. So again 1. Here we have h.
Okay, so we're matching them. X is
O
okay,
and
again,
convert it to
which
empty.
is
So we will
X,
delete
which
2
is
characters,
Y.
2, 3. To solve this, we need these 3 values. So if we start from this top and go row wise, then next row, then we will always have solved
This is Y, this is X.
these 3 parts before reaching here. These 3. Taken any character from x, that is x is empty, and we have to convert it to some one or more characters of this y. So this denotes x is empty, y is also empty. So we don't need any conversion, so this will be 0. This cell will denote that x is empty, y is this first character. So if x is empty, y is r. So what we will need, we will insert r. So it will require
So we
one
need
operation.
to go from X to Y.
And this will denote x is again empty and
From X to
y.
Okay, so edit distance is 72. So 72 is 0. 0. Actually, 72. Maybe Python has something? No, it does not. This doesn't even have. This doesn't even have a matrix. I will wait. I will. I thought I have a matrix. I need a matrix. from
is RO. So this denotes that take from beginning till this. Similarly, this value will denote that take HO and R corresponding to this. HOR convert it to RO. So here empty to RO, so 2, empty to ROS 3. We can only insert if it's empty, and here it's not empty. We will make 3 insertions. And similarly, this one. Here we will do deletion. X is H and Y is empty. This column, first column I am talking about.
21 deletion.
So here we will delete 1. So again 1. Here we have HO and convert it to empty. So we will delete 2 characters, 2, 3, 4, 5. Now we will see this cell. So this means convert H to R. We have taken till this point from Y, till this point from X. So this R and H are not equal. So in case of not equal, we will take minimum of these 3. So minimum of these 3 is 0. So 0 plus 1 is 1. So don't forget to add this plus 1 here. And here H and O are different. So minimum of these 3 plus 1. So it's 1. 1 plus 1, 2. Again not equal, H and S. So minimum 2 plus 1, 3. Now again not equal. So 1 plus 1, 2. Equal. So simply put this one, which is 1. Not equal. So 2, 1 plus 1. They are equal. So we will simply put this value.
This is more of an algorithm that you need to understand, and that the solution is not necessarily chosen in the code. What is the solution? It's just following the optimum path. You use this with those rules that you get from the algorithm. You just use the rules, and it's not important that you know what are the steps or how the steps look. You just follow the rules.
Now let's see why is that. So this cell denotes HOR. Take HOR from this and take R from this. So we will delete this, we will delete this. So we will require 2 operations, and you see that correctly it's being captured here. And here not equal. So minimum of these 2 plus 1. So it's 2.
So the algorithm will fill this matrix with those tricks, with those following those operations, and it's cool and all. You just send this one, return this one. You don't need to understand what does the algorithm do to return this one, to create the algorithm. But to debug it, you need to understand what it does. So you do all this to really understand, because if you
again HOR and RO, then why do we need 2 here? Why did we need 2 here? So we came from this side, minimum of this plus 1, and this is HORO. So HO to RO we converted by substituting H to R. So here substitute H to R, so it becomes ROR, 1 operation, and then delete this. So 2 operations, and that's being correctly captured here. It even gives you solution from where did we come. We come from this, minimum was this. So we'll look at why this was 1, because it was HO versus RO. This required 1 substitution, and we came to here from this, which is H and R, which will require 1 substitution. So it even gives you a solution what operations you need to perform, but here we need just count. Again not equal, so 2, not equal 3, not equal 3, equal, so this value 2, not equal 4 minimum plus 1, not equal 4, and now not equal minimum of these 3 is 2, 2 plus 1 3, and the solution here will be 3, and we had already seen here. Let me come here. So these are the three, this plus 1 and this is
Okay, these two are equals 1. Okay.
HORO. So HO to RO we converted by substituting H to R. So here substitute H to R, so it becomes ROR, one operation, and then delete this, so two operations, and that's being correctly captured here. It even gives you solution from where did we come from this, minimum was this. So we'll look at why this was 1, because it was HO versus RO. This required one substitution, and we came to here from this, which is H and R, which will require one substitution. So it even gives you a solution what operations you need to perform, but here we need just count. Again not equal, so 2, not equal 3, not equal 3, equal, so this value 2, not equal 4 minimum plus 1, not equal 4, and now not equal minimum of these 3 is 2, 2 plus 1 3, and the solution here will be 3, and we had already seen here. Let me come here. So these are the three edits. One is substituting H with R, then deleting R and E, and that is what we got here.
Okay. Put in the
So let's write the code for this. So first we will do it in C++. Let's stick to that convention that we have been using. M denotes the length of first one, and N denotes the length of second word.
Okay. He is not going to use a matrix because he's going to do it backwards. He's going to start here in the empty string, and he's going to go over there. Yes, that's pretty possible. And it's just going to do the algorithm but backwards. He's not going to start here and say, I need this solution, this solution, this solution, and you call it. Now he's going to go from here to over there. That is even more and even faster.
2.length. Next we created one array dp m plus 1 n plus 1. So if you followed that explanation, this code should be very easy for you. I equal to 0, I less than equal to m. So see here equal to m, so this will be done for m plus 1 times, which is same as here, I plus plus. If I equal to 0, that is it's the first row, the dummy row where x is empty, then dp I j is equal to j. You can see this table. In first row it's 0, 1, 2, 3, and in the first column it's 0, 1, 2, 3, 4, 5. Else if
if the first
j equal to
0,
dp I j equal to I. Else if word 1 I minus 1, that is last character, is same as word2 j minus 1, then dp I j
Goes to
equal to
many.
dp I minus 1 j minus 1, else min of 3 values I minus 1 j minus 1, I minus 1 j,
Back.
and I j minus 1,
It's not doing it back.
and finally we will
So
return
he doesn't need.
dp m n, and let's see. And this solution works. Let's try this one. And the answer matches with expected, so let's submit, and the solution is accepted. Now we will do this same thing in Java and Python, and for those of you who are concerned about the time complexity here, so the time that it takes is to filling
The time complexity is y times x.
of this dp table. And what is the dimension of this dp table? It's m plus 1 n plus 1, so its time complexity and space complexity
500,
both are
500.
O of m multiplied by n, O of mn. Although you will notice that here we don't need to store the previous values, we only need these three values.
25.
So we can optimize the space. So just do a quick rough work and you should be able to figure out how we can save the space. So space we can save, but time complexity would still remain mn. So now let's complete this code in Java.
And it's the same.
Min of
Blah blah blah. I'm just checking
this peak. Now,
as a full stack web developer, you need to be good at, well, everything. Full stack developer.
I don't know what I'm checking. I know how to solve it in Python. Okay, let's solve it. But I will try to understand it. Properties, automatic. Okay. So let's take that there. Okay. Okay, so colors and delete. And just delete everything. Let's just file new. Let's say. So horse, horse, 2 rows. Okay. There is 1 people here. String number 1 to 2. Okay, so what we're doing is R O S and empty and empty H O R S E R horse. That is not shine. Here, the same more and create a new one. Save more and okay, so empty R O S H O R S S E. So you can start from empty because the solution Y. From empty to the solution because this because it has an optimum solution. Seeing how to get to RO is optimum when you see how to get to ROS. And why is that? Okay, I think that is not as clear cut. So maybe we should look it up. But this is all the time I have for this. For this Pomodoro. And we will check that later. Save the string. Let's go and then distance and pictures. Okay, so bye. I will see you again probably today, but I'm going to rest a little bit. Okay, bye. See you again.